So the problem 4.3.21. So suppose we're given this quadrature formula, f of x, integral of f of x over interval -1 to 1. And then we're told to find the quadrature rule for this formula, where the function is evaluated at these 3 points, -1, 0, and 1. They are fixed. And the only thing that we can change are this c values, the coefficients. So now we have 3 unknowns, and we hope that this formula will be exact for all the polynomials of degree up to 2, because for polynomial degree up to 2, there will be 3 coefficients. So we expect that we can find this C0, C1, C2, so that this is true for all the polynomials of degree up to 2. Okay, so we want it to be exact for polynomials of degree up to 2. That means we want this to be true, want this equation to be true for f of x equal to 1 or x squared, because all the polynomials degree up to 2 can be represented as a linear combination of the 3 basis functions or basis polynomials. So we just need to plug in f of x equal to this 3 and check what should be the values of those c. So when f of x is to 1, then on the right hand side you can see f is a constant 1. So this just becomes c0 plus c1 plus c2. And then on this side, when we plug in f equals to 1, then this side is just equal to that. And you can take the integral, which is just 2. Now that's the case when we plug in f of x equals to 1. If we plug in f of x equals to x, then on this side, we see that this is just f function is just identity function. So we just need to see here that this is just negative c0, because f of -1 will be just -1. F of 0 will be just 0. F of 1 will be just 1. So that's why when we plug in those values of x, we get this on this side. And then on this side, when f of x equals to x, then we can calculate it, and that's just equal to 0. So similarly, you can do this for x equals to f of x equals to x squared in this last case. And then we can also get the equation for these 3 c's. So now we have 3 equations with 3 unknowns, c0, c1, c2, which reduce to this. Then we just need to solve for it. Solve for the constant c0, c1, c2, and that will be the results. So these are the values we should put in here.